Alright, the vertex is very important. In the last video, again, it's where my function either hits a max or min, and it determines my axis of symmetry and which side of the graph is increasing and decreasing. It's very important. It also does other things. I can actually find a quadratic equation if I know its vertex, and a little bit more information about it if I know its vertex and another point on my line, and we'll get to examples of those. The first one, though, is just introducing you to this. So just like lines had different ways we can write the function, like lines, we could write them in slope-intercept, point-slope, or the standard form. Quadratics have another form too. Right? The quadratic form has a standard form, which is this is the standard form. And it also has a vertex form, right? This is the vertex form, which again, the reason why it's called that is because in the form you have the vertex. Right? And it also has still the leading coefficient as well. Opens up, opens down based on that number out front, which can be positive or negative. But inside the vertex formula is the vertex. Alright, so if we know the vertex of my graph is h is the x value, k is the y value, and those would be real number values, then the quadratic equation would be I'd have to figure out the constants, why I need to know at least one other point when I need to go to find these. But it's always x minus the x value in the vertex squared plus the y value, whatever that ky value is. Alright, and that's the vertex form. And so we've got a couple of examples for you here where we've got the vertex form, and then we want to put it in standard form because we just like to have it in standard form. When we go to solve quadratics, the process that we use to solve involves the standard form. So we like to have the standard form. And so it does require you to do a little bit of work. So the first thing, again, follow order of operations. So order of operations is I have to take care of the square term. So I'm going to kind of go over here and talk about that square term. So I'm going to leave this alone for a second, and I'm going to kind of do work to the side. Remember what x plus 3 squared is. Right? X plus 3 squared, bigger pen. Alright, so work to the side, so this is kind of side work. So remember what x plus 3 squared is. It means squared means I'm taking the same thing times itself, right? 2 squared means 2 times 2, which gives me 4. 3 squared means 3 times 3, which gives me 9. X plus 3 squared, remember, really means x plus 3 times x plus 3, which is not... So what you have to be careful with, a lot of students want to just distribute the square term. You can't. It's not x squared plus 3 squared. You have to multiply it out. Alright, multiplying it out, which means I multiply the first term, so I get x squared, the middle term, which gives me a 3x, the outside term, which gives me another 3x, and then the last term, which gives me 3 times 3, which is 9. Alright, we always have this middle term. Alright, so what happens is, it's always the first term squared, and then you get this middle term. What it is, it's twice the product of the two, right? If I take x times 3, I get 3x times 2, I get the 6x, and then it's the last term squared. So you always have a middle term here, so make sure you're careful whenever you're squaring these out. There should be 3 terms that you get. And so using that knowledge, I'm going to simplify this. So f of x, so don't forget the 1/2 is out front. When I take 1/2 and I multiply the x plus 3 squared, this is what I get. So x plus 3 squared is x squared plus 6x plus 9. That whole thing still multiplied by 1/2. I'm going to have to distribute that 1/2 in a little bit. And then also, don't forget, I have a minus 5 is still there. So again, there's just a couple things that you have to make sure you're careful with. First of all, make sure you multiply the group squared correctly. Then remember the 1/2 is out front, so I'm going to have to distribute that. And the negative 5 is also outside it, so I have to take care of that later. So the next step is distribute the negative 5. So remember, distribute means everything in that x squared 6x plus 9 gets multiplied by 1/2. So I get 0.5 x squared. 0.5 times 6 is going to give me a 3x. 0.5 times 9 is going to give me a 4.5, and then I still have the minus 5 I have to take care of, and so that's the last step, is to take care of the minus 5. And so it simplifies to 0.5x squared plus 3x minus a half. I know it opens up because it's a positive square term, which means my vertex, which is the point, which I know from this, my vertex is my x value. Remember, it was minus, right? So this really would have been my vertex point x minus a negative 3 to get the plus, and then minus 5. And so my x term is negative 3 on my vertex, the h. The h part is negative 3, right? H part is negative 3. The k part is negative 5, right? Because the k part is plus, but it's a minus 5, so this gives me a negative out. And so my vertex is the negative 3, negative 5. And I know since it opens up, it's the minimum. Right? It would be the minimum value of my function. Negative 5 would be the smallest my function ever hits. Okay, so that's the vertex form. And you can check the graphically like we did last time. You can always graph it and double check that that actually is the minimum point. Right? And it is. Right? It's the minimum point is negative 3, negative 5 because it opens up. This is its standard form. Right? So you plug in the standard form, that should be the vertex. Alright, second example of this. Alright, so again, I'm going to simplify first, and then we'll talk about the leading coefficient, the vertex, and all that. Alright, so we're going to simplify first. So again, kind of work off to the side if you need to. Remember what the x minus 4 squared really is. It's really x minus 4 times another x minus 4, which means I get x squared minus, I get a negative 4x and another negative 4x, so it would be negative 8x. And then negative 4 times negative 4 comes out positive 16. Alright, and so that's what the square term, so again this will be scratch work off to the side, multiplies out to be. So f of x equals negative 5 times that squared, which was x squared minus 8x plus 16, and then don't forget the plus 2 on the outside. Next step, distribute the negative 5. And so we get negative 5x squared, negative 5 times negative 8 is going to come out positive 40x. Negative 5 times 16 comes out negative 80. And then don't forget I still have the plus 2 to take care of. And so the last thing is to do that. So negative 5x squared plus 40x minus 78 is the standard form. The a is negative 5, so it's less than 0, it opens down. Right, opens down, which means my vertex, which I'm going to list it in a second, is the maximum in this case. Alright, so what is the vertex? Well, I can look at my equation to determine that. Remember, the x minus h gives me my x term. So h is 4, right? Because it's x minus the h value. So x minus 4 means h was 4. And then the plus k, well, it is already positive, so k comes out positive 2. And that's hard sometimes because one of them's subtracting and one of them's adding, so you have to be careful. H is we take x and subtract h. So if it's a minus, it's the positive version. If it was a positive, it's the minus. Right, that's the hard part for students because it's just tricky. And then k is whatever k is. If k is positive, if it's minus, it's negative. And so in this case, it is positive. And so my vertex is the point 4, 2. And you can double check it. If you graphed that, you would see that that is the vertex, right? You graphed it. Now, you'd have to make your window a bit bigger. And I know that just based on the fact that these numbers are fairly large. It would shoot off pretty fast, but that would be the vertex, and it's opening down, so that should be the biggest value my function hits. Biggest value my function hits is 4, 2. Alright, so again, the quadratic equation with the vertex formula. Alright, so the vertex formula. Next examples we're going to look at is, well, we're going to find the vertex formula. Alright, based on our function given a vertex and a point, I should be able to determine the equation of my quadratic equation. Alright, so an example, first example, suppose we know, alright, suppose we're given a graph. Alright, so this is the graph that we're given. Alright, so we're given that it goes through so there's my function f of x. This would be the vertex at 2, 1. And then it goes through, they give me a couple points. That would be 3, 0. That would be 1, 0. And then they also give us this point 0, negative 3. Because you usually use multiple points to graph the function. So we have a lot of options in this case, and I'm going to talk you through which is the easiest one. Right, now there's more than one way you could do this, and it's fine. If you choose to find the answer using a different point than I did, that's perfectly fine. Alright, so given the graph, the point in you have to always use the vertex. So the vertex was the point 2, 1. And I'm going to pick, I need one other point, and there again, there were multiple points that they gave me. The easiest one to use is if they give you the y-intercept. Now they gave me the x-intercepts as well, and those are actually not too bad either, but it's actually easiest to use the y-intercept. So if you want to use the other 2 points and solve it, you can. But the point I'm going to use is 0, negative 3, because it's the easiest. Alright, so those are the thing. And the second thing, again, I need to remember is that A is negative, so keeping that in mind because it opens down. So that's kind of the information I know. Alright, so remember, the vertex form of an equation is A times x minus h squared plus k. Well, the h comes from the x value in the vertex, so h is 2. The k comes from the y value in the vertex, which k is 1. Right, and those are the 2 pieces I'm going to plug in first. Alright, so I still have the a, I don't have that yet. That's why I need the second point so I can figure out a. Okay, so a is still there, but this time I do have an h value, which is 2, so it's going to be x minus 2 squared. I have a k value, which was 1, so it's plus 1. So there's the start of the vertex. Now what I don't have yet is the A. Remember, the A is important. It tells me whether I open up or open down and if I'm fat or skinny. How fat and how skinny, actually, it tells me that. And so that is why we need at least one other point. Right? Again, I had multiple points to choose from. I picked the point 1, 3, which means when I, or 0, 3, negative 3, when I plug 0 in, I should get negative 3 out. Which, this is the easy case. Whenever I can plug 0 in, it's the easy case. Right, so again, you could use one of the other points. If you use the other points, you would have 1 and have our function equal to 0, and you could solve that too. It's just a little tougher. It's always easier when we have the vertex. Alright, which means that's what I'm going to do. I know I'm going to get negative 3 out when I plug 0 in. Alright, so negative 3 equals a times 0 goes in for x, minus 2 squared plus 1, and then solve for a, which again, that's why the 0 is nice. I get a times my negative 2 squared plus 1. So remember, negative 2 squared comes out 4, positive 4. Excuse me. Alright, now I solve for a, move the 1 to the other side, so I get a negative 4 equals a times 4. Divide by my 4, and so a comes out negative 1. Alright, again, it should have been negative. I knew it was going to be negative, and so there's my a value, and now I plug it back into this equation now that I know what a is. Alright, so the actual final answer is my function f of x equals negative 1, or just negative, a lot of times we'll put out in the front, negative x minus 2 squared plus 1. If you graphed that function, Right? It should have a vertex at 2, 1. It should have an intercept at 3, 0. And it should have an intercept at 1, 0. Or actually, the 1, 0 is the easiest case. If I wanted to check my answer real quick, I know that when I plug 1 in, I should get 0 out, right? That's what the 1, 0 point is. And so if I plug 1 in, negative 1 times 1 minus 2 squared plus 1. This is just a check. You don't have to do this. This is just me checking my answer. And so what's going to happen here is I have the negative out front, and I get a negative 1 inside squared plus 1. Well, negative 1 squared is 1, but then I have the negative out front, so it comes out negative 1 plus 1, and that does give me the 0, and so my answer checks. I was just checking my answer, right, but this is the correct case. Let's do another example. Maybe. Where's my second example? Oh, I have to write it out. Alright, my second example. Suppose we know that a parabola has a vertex of 3, 1 and passes through the point 1, 9. So this time we didn't give a graph, but they did give us enough information to solve the problem. As long as I know the vertex and one other point, I can solve it. Now this point is not quite as easy as the last example. It's always nice when we have zeros, but I can still solve it. So remember, the equation is a times x minus h squared plus k, where h comes from the x value in my vertex, so h is 3, k comes from the y value in my vertex, which is 1, so that's where we start. So a times x minus 3 squared plus 1. And then I use the other point. So I have the point 1, 9, which means the x value is 1, the y value is 9. So when I plug 1 in, I should get 9 out. Right, so I know I get 9 out when I plug 1 in, and so that's what we do. So I set it equal to 9, and I plug 1 in for my x value. So a times 1 minus 3 squared plus 1, and then solve for a. So in this case, I'm going to simplify in my parentheses first. So a times negative 2 squared plus 1. So my a start to look like a 9. A times 4 plus 1. Move the 1 over. So I get 8 equals 4 times a. Divide by my 4. And so 2 is my a value. So it's a positive 1. Opens up this time. Alright, so then the final answer is, well, then go back here and now plug my a value in. Alright, so we got a was 2, and so the final answer is f of x equals 2 times x minus 3 squared plus 1. And if you graphed it, it should go through the point 1, 9, and it should have the vertex at 3, 1. And you can always check your answers graphically if you want to. Alright, so there is an example of finding a quadratic if we know the vertex and at least one other point. Alright, we'll stop there.